Go.
Hello. Yeah.
Okay.
Oh, yeah.
Hello. Hello. Hello, Eric. Hello, Ryan.
Hello.
Okay, so remember a few days ago we talked about the trees and breakfast search, right?
Binary search.
No, breakfast search, BFS.
I don't remember breakfast search.
Eric, do you still remember? It's a bit, yeah, that's okay, you don't remember, but look. B stands for breath. What does it mean? Eric?
What?
What does this word mean? Breath. Take a guess.
I don't know.
Ryan, do you want to take a guess? Breath. As opposed to depth. Do you know what this means?
No.
Deep. Deep. Yeah? So look, if this is a tree, remember? Eric, look at daddy, please.
Yeah.
This, that's the root, yeah? Eric, look. Ryan, if this is a tree, the depth is this dimension, yeah? This is the depth, right?
Mm-hmm.
The breadth is this dimension, horizontal, so it's broad, horizontal, breadth. So look, if this is the tree, like this is A, B, C, D, E, F, G, H, I. Okay, so breakfast search, BFS, will give the order A, B, C, D, E, F, G, H, I. Okay, do you get it?
Mm-hmm.
So you will travel level by level. Depth first search, DFS, depth first search. It goes this way. Can you take a guess? A, B, D, H, I, E, C, F, J. So basically, I want to go. Okay, G. I want to go as deep as I can. If I can't go deep here, then I go to the right. Yeah.
Mm-hmm.
And like go back, visit the E, and then go back, C and F, G. Okay? Yeah, that's DFS. So how does that help? So look, that's an interesting problem today. Yeah, that's an interesting problem. Let's say, let's a list like 2, 0, 3, 1, 5, 2, 3, okay? 3 and 4. Let's see. So let's a list. If I give you a starting position, like here, yeah, this is your starting point. Suppose Eric and Ryan, you are here. Eric, Ryan,
Hi.
yeah, you're here, yeah? So now you are at this point, yeah?
Number 1.
Yeah. 1 means that at this point you can jump forward 1 or jump backward 1, right?
What about 0?
That's okay. 0 is the destination, target, destination, yeah? So you're here, everyone, you're here. And you can go this way or go this way, 1 step, right? If you go this way, if you're here, then you can choose go 3 steps more, but there's no more, so you can't go that way. But you can jump backwards 3 steps, 1, 2, 3, and then you reach the destination. Yeah. But if you here, if you go to here, then you can jump 3 forward, 1, 2, 3, yeah, and then you can do 1, 2, 3, 4, or you can do 3 more.
You only can do 3.
Yeah, because you are at 3, then you can jump forward or backward 3. Yeah.
Yeah.
Okay, so this is an interesting problem. So given a list, this is the list. So we call it N. Okay, let's just call it N. This is the list, and then you have starting point position as S. Okay, and then you want to find out if you can reach the 0 by this way. Yeah. Is it interesting? This is an interesting one, okay? So how do we do this? We use the breakfast search. So this is the breakfast search. You did, remember how, so we have a queue, yeah? Can you remind me what is the queue? Eric, Ryan, what is the queue? first out. First in, first out. So we use the bracket. This is the queue, right? Eric, here. So this we are currently at this position. This position is 0, 1, 2, 3. Alright? We are currently at 3. Index 3. Eric, can you look focus, please?
You're just asking me, not right.
Okay, Ryan. Yeah, we are at 3, so we push it into the queue. Right? 3 here. So now, if we take a 3 here, then can you tell me how many next position can we have? We take the 3 out. And what's the next position could be?
Position.
Hmm?
It could be position. 4.
Yeah, and then this one, yeah? So it could be, this would be 4 and 5, right? Okay? And now?
5. There's only 5.
Oh no, 4 and 2, right? Yeah? Because we could choose this way and this way, right? 1, yeah? Am I right?
Yeah.
So now we take the beginning, which is 4. What's the 4? Which is 4? For the next position will be, Eric? If I'm here, what's the next position could be? It can't be over the boundary, so it can be only this way, yeah?
Yes.
So that will be 0. Black will be 1. And then and
I thought
you-
we allowed to make
2, 1.
3.
yes, 2, 1. And then 2 is here, so we can have 1, 2, 3. That's 5.
No, look. 1, 2, 3. Not 1.
Sorry, which one?
4. It isn't 1. It is 3.
It can't go this way, right? So it could
Yeah.
be. We are here, and then that's 3 step. 1, 2, 3. So that's 0, 1. That's the one I mean 1. Index 1. This is
Oh.
index 1. And then I take a 2. What's the next? 0, 1, 2. It could be 3. 2 more. 3 more. That will be 5. And then 3 less will be nothing, right? So I put it 1, 5. Okay. And then 1. Yeah. Look. 1. We are at target. So we return true, right? Do you get it? Okay?
At the beginning.
Now 1, look, we have a queue. Every time we take the beginning of the queue and push its next step, either forward or backward into the queue. Alright? Until we run out of the items in the queue, or we find the 1, which is 0. That's our target.
Why 0, 1? Plus 2.
Which one?
Why 0, 1? You write it down as 1.
Index. That's the index. 0, 1. That's the index. That's the current position. Okay. This is that's the index, and n1 will be 0. Okay. We are looking for the destination 0. So let me write it down, then you can have a look. And I will have a few blanks for you to guess. Okay, that's so. First of all, Def, yeah,
Definitely.
BFS. We take in a number,
I thought
a list of numbers, a list of number, and the starting position. What am I missing here?
column.
That's a good job. So now we have a Q, which is bracket empty, right? First of all we check if the given length is empty, then we just return false, right? We say it's not possible. Return false. It's not possible. Okay. Otherwise we put actually we can move this layer.
What? I already written down that.
That's okay. You can keep it. That's okay. Q equals the first step is the first of all we put an S into the queue, right? We put an S into the queue. So there's only one item in the queue. So now we need to say why length the queue is not empty. Right? This means that the queue is not empty. There are still elements in the queue. we take the first element. So the current step will be, let's say now, let's put it now, equals q dot pop 0, right? Remember, we use the pop 0 to pop the first element in the queue. Remember this? Remember, if let the queue is 1, 2, and then look, if it's 1, 2, and q dot pop 0, we take this away, and then now will become 1, okay? Let's dot pop 0.
I never see the word now in Python.
Sorry?
I never seen the word now in Python.
That's the variable, you can call it any, or maybe you can call it Eric, you know, it doesn't matter. Yeah? We're gonna call it Eric or Ryan. Yeah?
I'm not sure.
Or call it ER. Let's call it ER, okay? Stands for Eric and Ryan. Can we? Yeah, so now Eric and Ryan is at this position. And then what should we do? We should check if the next position, which is...
Do you need this full stop?
No, there's no full stop. You know, in Python, every line has only one statement. You can use the, what's this?
Semicolon.
Semicolon. For example, you can say A equals 1 and semicolon B equals 1. It's the same as A equals 1, new line B equals 1. Or it's also the same as A, B equals 1, 1. Okay? There are 3 different ways of doing it. So here, remember, if we are at this position and we can jump 3 steps more, or go back 3 steps, right? We are Eric Ryan is here, and then the next position will be ER plus N. So now this is ER, the ER plus NER, right? Right? And or ER minus NER. So there are 2 positions to go. So we can do this is for I in, because it could be plus or equal, right? Minus 1 plus 1. If it's plus 1, it means to go forward. If minus 1 is go backward. And the next position, next, let's call it next, equals now will be ER, right? We are, Eric and Ryan is at ER position. And then the next position will be I times, because it's plus 1 or minus 1, times what? Times N ER, right? Yeah, so but again, we need to check the position here. So I'm keeping writing down that way, okay? Okay, then if what? ER, if next bigger than 0 and next smaller than equals than length n, right? Because it can't go smaller than length n, because it can't go beyond the boundary. Then we need to push q dot append next. Okay, so there's a slightly tiny problem here. Look, what if an array is here, right? If it's not currently is 1, if it all 1, right? Look, if ER is here, now we are jumping 1 step forward, right? But the next time it could be jumping backward again, right? And then you're jumping forward, backward, forward. So you see the loop, right? It means that, so we need to check if the step we already visited, then we don't jump because we have jumped it before, right? Otherwise, if it is 1, if Eric is here, Ryan is here, you're jumping forward, and then you're jumping backward, jumping forward, jumping backward, jumping forward. The program. Yeah, I know, but you never end, right? So we need to avoid the situation like that. So we have this scene. Let's call it scene.
Are you kidding me?
That's why I left a space here. Scene, or we call it visited or memo. We call it as a dictionary. Right? Maybe we call it a set. Remember? We call it a set.
And scene.
Scene.
I'm just gonna roll it.
So what's next? So look here. If next we need to add here, right? We need to add something here, right? Okay, I'm going to write here. Okay. So if in scene. So if not, next not in scene, okay? If next not in scene, then we do this. Then we can add this scene dot add next. So this will avoid us to repeatedly jumping backward and forward. Okay, and then where do we check it if they're already there? So look, if ER is right, if we are currently at this position, and we add one more here. If n ER equals 0, means we already do it, right? Return true.
Do we have a space here?
Yes. And then otherwise, after this while loop, what do we do? Return what? Can you tell me what should I return here?
False.
False, yes. Because if we are running out of choice, we return false. Is it clear? This is very interesting problem, yeah. Ryan, do you see this?
Do you write this in below here?
No, this is right here, below here, and then this is.
Are you kidding me?
This is below the y, and this is the next before, because now we are checking if it's inside the boundary, right? We don't want to check beyond the boundary, and then we also need to check if this is the position we never visited before, right? We use the scene, right? The notebook, yeah, notebook. Okay, this is the notebook. Remember, we put down the positions we already visited here, right? Do you get it?
Yeah.
Okay, so this is called the breadth-first search. Yeah, I'm going to come back to this topic because this is very important in the future, right? This is one of the most important algorithm. Yeah, how do you pronounce this? Algorithm. Can you pronounce this?
No.
Ryan, can you pronounce this?
Algorithm means a way. No.
No, algorithm. Okay, algorithm.
Algorithm.
Okay, more or less.
Algorithm.
Yeah, algorithm. Perfect. Okay. Okay, so yeah, I'm going to watch you put it in the computer. Okay, last thing, please.
Say goodbye. Bye.
Bye. Oh, babe.
Bye bye.
Oh, yeah.